Welcome to another lecture on engineering graphics. Today we will learn about projections of points. In this lecture, we will learn how to draw front view and top view of a point. So let us start the lecture. We know that in this course, we want to learn how to draw different views of an object. But in order to understand this, first of all, we have to learn how to draw different views of point, lines, and planes because objects are made up of these three elements. So once we develop the knowledge of projections of points, lines, and planes, then it will be very easy for us to understand how to draw different views of an object. So in this lecture, we will focus on projections of points. Now in this lecture, we will see 9 cases of a point, and I have made statement for each case in order to understand each case better. So let us start with the first case of a point. So let us read the statement. A point capital A is 30 mm above HP and 40 mm in front of VP. Draw projections. By projections, we mean that we have to draw front view and top view of this particular point. So let us understand this case 1 through example. Now over here quadrant system is shown and observer position is also shown, and we know that observer position is such that he can see only first and fourth quadrant. So case 1 of point is related to first quadrant. So let us read the statement again. A point A is 30 mm above HP and 40 mm in front of VP. So this word above HP and this word in front of VP tells us that point is in the first quadrant, because in the first quadrant the position of the point is defined as above HP in front of VP. This we have learned in quadrants lecture. So let us place the point in the first quadrant. So name of the point is capital A. So over here he says 30 mm above HP. So it is placed at 30 mm from HP, and it is 40 mm in front of VP. So if we have to draw the front view of this point, then what will happen? The rays of sight from the eyes of the observer will strike the point, and those rays of sight will project the image of the point on vertical plane, and that image will be called as front view of the point. And we denote front view of a point with the small letter single dash. Over here in this case, the name of the point is capital letter A. So over here we have denoted its front view with the small letter A with single dash at the top. Over here we have to make one very important observation. The point was given at 30 mm from HP. So distance was given from HP, but when we will draw its front view, we will find that that distance is actually visible on VP. So this is the first important uh, thing we have to note, that if in a statement we are given distance of a point from HP, that distance will be visible on VP. Now let us draw its top view. So in order to draw the top view, observer has to change his position. He will see the point from top. Now again, fundamental is same, means rays of sight from the eyes of observer will strike the point, and those rays of sight will project the image of the point on horizontal plane, and that image will be called as top view of the point. And we denote top view of a point by small letter only. So over here name of the point is capital A, so it is denoted as small a. Now over here again one important observation we have to make, that when observer looks from top, the distance which was given in the statement from VP for the point is actually visible on HP. See, this distance of the point was given from VP in the statement, but when we draw the top view of this point, then that particular distance will be visible on HP. So over here we have to conclude that if we are given a statement in which we have to draw projections of a point, and if we are given the distance of point from HP, we have to plot that distance on VP, And if we are given distance of point from VP, we have to plot that distance on HP. Okay, so let us remove the dimensions in order to understand the next procedure. Now you see we have obtained front view and top view of the object. Front view is obtained on vertical plane and the top view of the point is obtained on horizontal plane. Now we know that this is in 3D, and of course we work on paper, so we work on 2D. And in the previous lecture on quadrants, we learned that in order to convert 3D solution into 2D, we rotate HP clockwise by keeping VP stationary. So if we do this for first quadrant will open and HP will move down. So let us rotate HP clockwise and keep VP stationary. So we will get this solution. So first quadrant takes the shape of a paper, and on that paper we will draw one line, and the space above that line on the paper will be considered for VP, and space below that line on the paper will be considered for HP. And front view of the point will be drawn on vertical plane, and top view of the point will be drawn on horizontal plane, and these 2 points will be in the same line. Okay, now we will learn how to solve this problem on paper. So we have learned this case 1, and now we will see its solution. So let us understand how we can solve this case on paper. So whenever we are solving any problem on points, the very first step is we have to understand the quadrant of the problem. So we have seen that we are given distances above HP and in front of VP. So above, in front means the point is in first quadrant. So after identifying the quadrant of the problem, we have to draw that quadrant on the paper. So how we can draw? We have to sketch one line, continuous thick line, and we will label that as capital X, capital Y. So we will call that line as reference line, and we have to represent first quadrant on paper. So how we represent first quadrant on paper? We will label VP above reference line and HP below reference line. Now in third step, we will mark a point somewhere at the middle of the line, and we call that point as reference point. From this point we will start our drawing. If the name of the point is given as capital A in the problem, then this reference point will be labeled as a small letter A with naught at the bottom. Now in the fourth step, we will read the statement. So he says a point A is 30 mm above HP. So when we were discussing this case in the quadrant system, then we found that any distance given from HP is actually visible on the opposite plane, that is VP. So same method we will apply in the solution. So we are given 30 mm above HP. So we will show this distance on VP. So VP is over here. So we will place our scale on this point, that is the reference point, in vertical position, and from this reference point we will draw continuous thin line which is called as projection line of 30 millimeters, and we will make the end of that line bold to show the view of the point. And this is which view? This is obtained on vertical plane, and on vertical plane we always get front view. So this is the front view of the point, and we learned that we denote front view by small letter A single dash. So we are ready with the first answer, that is front view of the point. Now we have to draw the top view of the point. So how to draw? For that we will read the statement again. In the next part of the statement he says 40 mm in front of VP. So distance is given from VP. So we have to plot that distance on opposite plane, that is HP. So from the reference point we have to plot 40 mm length, which will be continuous thin line. We call that line as projection line on horizontal plane, that is the opposite plane. So where is that plane? Over here is that plane. So from reference point, we will align our scale with this vertical line, and from reference point we will measure 40 millimeters and we will draw a continuous thin line, and we'll make the end of this line bold to show the top view of the point, and we label top view of the point with small letter only. So name of the point over here is A, so we are labeling it as small letter A. Now we are ready with front view and top view of this point. Now after that we have to place dimensions. So for that what we will do, from this view we will leave 1 mm gap and we will draw extension line, and then we will place dimension line by keeping 10 mm gap between projection line and dimension line. After that we will place dimension for this particular view also. So from this view we will leave 1 mm gap and we will draw extension line and we will draw dimension line. Again, gap between dimension and projection line should be 10 millimeters and we will place dimension. So this is the final answer to the first problem, that is first case of a point. Now we will understand the second case of point. Now let us read the statement first. A point B is 30 mm above HP and 40 mm behind VP. Draw projections. So by projections we mean we have to draw front view and top view of this point. Now let us first understand the quadrant of the problem. So over here he says above HP, behind VP. So anything above and behind means second quadrant. It means case 2 is related to second quadrant. Point is placed in the second quadrant. So let us understand this through the quadrant system, then it will be more clear to you. Now he says point B is 30 mm above HP. So this is HP. Above means this side, and next he says behind VP. So for observer, this side is behind VP. So it means above HP, behind VP. He is talking about second quadrant. So let us place the point in the second quadrant, and name of the point is capital B. Now over here two distances are shown. He says 30 mm above HP. So distance of the point from HP is 30 mm, and then he says 40 mm behind VP. So distance of point from VP is 40 mm. Now in this case we know that we are dealing with second quadrant, and we have learned in the previous lecture of quadrants that in second quadrant we assume VP as a transparent plane in order to draw the front view of the point. So if this is a transparent plane, now observer can see through. So what will happen? Whatever observer will see, observer will plot that image on the vertical plane, and that will be called as front view of the object. And we know that we label front views by small letter single dash. So name of the point in this case is capital V. So that is why we have labeled its front view as small letter single dash. Now very important observation again we have to make over here, that the distance of point B from HP was given as 30. It was given from HP, but this distance is actually now visible on VP. So again we have learned that if we are given distance of a point from HP, we have to show that distance on the opposite plane, that is VP. Now let us plot its top view. So for that observer has to change his position. He has to look from top. Now rays of sight from the eyes of observer will strike the point, and those rays of sight will project the image of the point onto horizontal plane, and that image will be called as top view of the point. And we know that we denote top view of any point by small letter. Now again we have to make another important observation, that the distance of this point from VP was given 40 millimeters, but when we see from top, that distance is actually visible on HP. Okay, so after this what we do? In order to bring this solution in 2D, what we do? We rotate HP clockwise by keeping VP stationary. So we know that when we will do this, second quadrant will close, both VP and HP will overlap. Fine. Now over here you can see that VP and HP will overlap, and we will get two views of the point. One is called as front view B dash, second is top view, that is B. Now let us see how we can attempt this problem on paper. So as we have discussed in the first case, that if we want to solve any problem on projections of a point, the very first step is we should identify the quadrant of the problem. So from these two words, above HP, behind VP, quadrant is clear. Quadrant is second quadrant. Okay. Now next step is we should plot that quadrant on paper. So in order to plot second quadrant on paper, what we have to do, we have to sketch reference line and we will label that line as capital X, capital Y. And we know that if we have to represent second quadrant on paper, then we have to mention the space above the reference line as VP and HP, because VP HP both overlaps and the position of both the planes in the second quadrant lies above the reference line. Now in the third step we mark a reference point on the reference line and we label that point as small letter naught. In this case the name of the point is capital B, so we'll label it as small letter B naught. After that, we have to plot the front view and top view of this point. For that, we have to first read the statement. Now over here he says 30 mm above HP. And we have learned from the previous discussion that we have to show that distance on opposite plane. 30 mm above HP, so show it on VP. So where is VP? VP is above XY line. So we will align our scale with this point in vertical position, and from this point we will draw a continuous thin line of 30 millimeters. We call this line as projection line or projector, and we will make the end of this line bold in order to show the view of the point. And let us see this is which view. He says 30 mm above HP and we say that plot that distance on opposite plane on VP. It means we have plotted this point on VP. And we know on VP we always draw front view. It means this point is the front view of the point. So we will label it as small letter B single dash at the top. Now let us plot its top view. So again we have to read the statement. He says 40 mm behind VP. So it is the distance given from VP. It means we have to plot that distance on opposite plane, that is HP. So let us see where is HP. In second quadrant, HP also lies on the same side, that is above reference line. So again what we will do, we will align our scale with this vertical line and from this reference point we will measure 40 millimeters and this line will be continuous thin line and we call this as projector. And we'll make the end of this line bold to show the view of the point, and this is which view? This is top view of the point, and we label top view with a small letter only. Now one important observation we have to make. Normally students get confused in the second quadrant. They get confused at which point they have to label B dash or the front view and which point they have to label top view or B. So how to get rid of this confusion? See the statement again. He says 30 mm above HP. It means we have to plot that distance on VP, and on VP we always draw front view. So when you will draw a line of 30 mm, then that line you are drawing on VP. It means on VP we label only front views. So we have to label that point as B dash. So if you will work like this, then there will be no confusion in labeling B dash and B. So after this we have to place dimensions. So from this point we will leave 1 millimeter gap, we will draw extension line, then we will place dimension line. After that we will draw another extension line from this point and we will draw a dimension line. And you should note one important point over here regarding rules of dimensioning, that gap between first dimension line and projector is 10 millimeters, minimum 10 millimeters. Then between two dimension lines again it should be minimum 10 millimeters. And one more thing we can understand over here, that when we have to solve problems related to projections of point, then we should keep notations on one side of the projector and dimension lines on other side of the projector. So then our drawing will be more clear to the reader. So I hope this second case is also clear to you. Now let us move on to the third case. So let us read the statement. A point C is 30 mm below HP and 40 mm behind VP. Draw projections. So we have to draw front view and top view of this point C. But before that, we first have to see the quadrant of the problem. So over here he says below HP and behind VP. So anything below and behind means third quadrant. So this point is in third quadrant. So this case is related to third quadrant. So let us understand this case through the quadrant system. So over here quadrant is shown and this is the third quadrant. Let us read the statement again. Point C is 30 mm below HP and 40 mm behind VP. So let us show the position of the point. So it is 30 mm below HP and 40 mm behind VP. So distance from HP is 30 and its distance from vertical plane is 40 millimeters and it is behind VP. Now let us draw its front view. Now we know that in the third quadrant we have to consider both planes VP and HP transparent if we want to draw the different views of a point. So let us consider VP transparent. Now observer can see through the plane. So in order to get the front view of the point, whatever observer will see through the plane, observer will draw that onto vertical plane. So that will be called as front view of the point, and we label front view by small letter single dash. After that, if we want to draw the top view of the point, then observer has to change his position. He has to look from top. Then again, we have to assume HP transparent, and if HP is transparent, now observer can see through the plane, and whatever observer will see, then observer will draw the same on horizontal plane. So that particular image drawn on HP will be called as top view of the point, and we denote top view by small letter. Now after that, what we will do, after obtaining front view and top view of the point, we will rotate HP clockwise by keeping VP stationary. So if we do this, what will happen? HP will move in our direction and VP is stationary. So we will get these two planes in a line, or they will take the shape of single plane. Or we can say this is a single paper. On that paper, one reference line is drawn. Space above the reference line is considered horizontal plane, and space below the reference line is considered as vertical plane. And on horizontal plane we draw top view of the point, and on vertical plane we draw front view of the point, and these 2 points will be in line. Now let us understand how to draw this case on the paper. So again, if we want to solve this case, first of all we have to see the quadrant of the problem. So we know it is given below HP, behind VP, it means quadrant is third. Now second step is draw that quadrant on paper. So how we draw third quadrant on paper? We will first draw a reference line. We will label it as X, Y. And in third quadrant we know that space above reference line will be considered as HP and space below reference line will be considered as VP. So above reference line will mark HP, below reference line will mark VP in Gothic style. Now after that, what is the third step? Third step is we will mark a reference point on the reference line and we'll call it as small letter C naught, because in this case name of the point is capital C. Now we have to draw front view and top view of this particular point. So for that we have to read the statement. So what he says, 30 mm below HP. Below HP means we have to plot this on VP. It is given distance from HP. So plot on opposite plane, which is VP. So where is VP? VP is here. So we will align our scale with this reference line in vertical position, and from this reference point we will draw continuous thin line of 30 millimeters on VP, and we'll make the end of that line bold. And this is which view? This is front view, because on VP we always obtain front view, and we denote that point with small letter single dash. Now let us plot its top view. So for that we have to read the statement again. He says 40 mm behind VP. So it is given from VP. It means we have to plot this distance on opposite plane, that is HP. So where is HP? HP is above reference line. So we will align our scale with this vertical line, and from the reference point we will draw a continuous thin line of 40 millimeters on HP, and we will make the end of that line bold, and this point will be called as top view of point C, and we label top view with small letter only. Now we are ready with front view and top view of this point. After that we will place dimensions. So we will leave 1 millimeter gap, continuous thin line which is an extension line. We will place dimension line. After that we will leave 1 millimeter gap over here to draw the extension line, and we will draw dimension line. And you can see that over here we have followed chain dimensioning. I hope the third case is clear to you. Now let us move on to the next case. The fourth case. Now let us read the statement. A point D is 30 mm below HP and 40 mm in front of VP. Draw projections. So let us first see what is the quadrant of the problem. Over here he is saying below HP in front of VP. That means fourth quadrant. So let us understand this situation through the quadrant system. So over here fourth quadrant is shown, and let us see the statement again. He says point D is 30 mm below HP and 40 mm in front of VP. So let us show the position of the point. So it is 30 mm below HP and 40 mm in front of VP. So in this case, if we have to draw the front view, then what will happen? The rays of sight from the eyes of observer will strike the point and will project the image of the point onto our vertical plane, and that will be called as front view of the point. And we denote front view by small letter D single dash. Then in order to get the top view of the point, observer has to change his position. Now you can see that in fourth quadrant we have to assume HP transparent in order to get the top view of the point. So if HP is transparent, observer can see through. So whatever observer will see, observer will draw same on the horizontal plane, and that will be called as top view of the point. And we denote top view by small letter D. Okay, let us understand what we will do next. Now we have obtained front view and top view of the point on vertical plane and on horizontal plane. After that, we know that we rotate HP clockwise in order to convert this 3D solution into 2D by keeping VP stationary. So if we will do this, we know that in fourth quadrant both VP and HP overlap, and over here both the views of the point are shown. Front view is marked as D dash and top view is marked as D. Now let us understand how to attempt this case on paper. So as we know that whenever we are solving any problem related to projection of a point, the first step is that we should understand the quadrant of the problem. So in this case he is saying below HP in front of VP, that means quadrant is fourth. So second step is draw that quadrant on paper. Now how we draw fourth quadrant on paper? We first draw reference line, we label that as XY, and space below the reference line on paper will be meant for VP and HP. So over here we will write VP slash HP. Now third step is mark the reference point on the reference line, and after that we have to plot front view and top view of the point. So for that we have to read the statement. So he says D is 30 mm below HP. So distance is given from HP. So we have to plot this distance on VP. So where is VP? VP is below the reference line. So we will align our scale in vertical position with this reference point. And from this point we will draw a continuous thin line of 30 millimeters. And remember, it is given from HP and we are drawing it on VP. So we will make the end of this line bold, and this point is on VP. So it is the front view of the point, and we will denote it by small letter D single dash. Now in order to get the top view, we have to read the remaining part of the statement. Over here he says 40 mm in front of VP. So distance is given from VP, we have to plot this on HP. So we will align our scale with this vertical line again, and HP is also on the same side. So from the reference point we will draw another line of 40 millimeters, and we'll make the end of that line bold, and that would be the top view of the point, and we denote top view by small letter only. Then after that we will place dimensions by using parallel dimensioning. Let us understand fifth case of projections of points. So the statement is a point E is 30 mm above HP and in VP. Draw projections. So in this case the point is not in the quadrant, it is in the plane, it is in VP. So let us understand this situation through the quadrant system. So he is saying point E is 30 mm above HP and in VP. Over here we are shown two planes, one is vertical plane and second is horizontal plane. Now focus on vertical plane. For vertical plane we have two halves, one half is above HP and other half is below HP. Now when he says in VP, then we must understand that there are two halves of VP, then we have to think that about which half of VP he is talking. So over here he is saying 30 above HP. That means he is talking about that half of VP which is above HP. So it means point E is in this part of VP. So let us show the point. So this is point capital E and it is in VP and it is 30 above HP. Now for this situation, if we have to draw the front view, then we will say that rays of sight from the eyes of observer will strike the point and point itself will be called as its front view. And we will label that view with the small letter E dash. Now if we have to draw the top view of this point, then observer will change his position and he will look at the point from top. Then again rays of sight from the eye of observer will strike the point and those rays of sight will project the image of point onto reference line. So that image on reference line will be the top view of the point and we label top view with small letter only. Now let us understand what we will do next to obtain the solution. Now in this case we have to understand a very important point, that the point is in VP. If the point is in VP, then we are not concerned about HP because HP has no role in deciding the views of the point. Because we have seen that if the point is in VP, then front view will lie on VP, means point itself is its front view, and its top view will lie on reference line. It means HP has no role when point is in VP. So when we say that rotate HP clockwise to obtain the final solution, then there will be no change in the solution. Mean when we will rotate HP, it will play no role because point is only in vertical plane. So we will ignore HP totally and we will only consider that half of VP which is above HP. That means this half. It means our final solution will be this only, that we will draw VP only which is above HP. So if we have to represent this situation on paper, then what we will do, we will just draw a line on paper and we will consider space above the line on that paper as vertical plane and we will not mention horizontal plane because it is not a case of quadrant, it is a case of point in the plane. So we will only mention that plane in which the point is lying. Now let us see how we can solve this case on paper. So for that, let us read the statement again. A point capital E is 30 above HP and in VP draw projections. Now from the previous slides, we understand that if the point is in a particular plane, that we have to represent that plane only. There is no need to represent other plane. And in the previous slide, we have seen that for this particular situation, we will consider that half of VP which is above HP. And in order to represent that situation, what we will do, we will just draw XY line, that is reference line on the paper, and space above that reference line on the paper we will mark as VP, and there is no need to mention HP because point is only in VP. Now let us plot the different views of this point. So next step is we will mark a reference point on the reference line and we'll call that as small letter E naught, and we will align our scale with this reference point in vertical position and we will read the statement. Now statement says 30 above HP, means plot on opposite plane, that is VP. So where we have marked VP, VP is marked above the reference line. Then from this reference point we will draw a vertical line of 30 and this line will be continuous thin line. And at the end of this line we will mark a point, means we will make the end of this line bold and we will label this point as small letter E dash because it is drawn on the vertical plane, so it is the front view of the point. And we have learned in the previous slide through the quadrant system that when the point is in VP and it is some distance above HP, then its top view lies on the reference line. So what we will do, we will label the reference point as its top view. We will label comma top view with small letter E. So after that we will place dimension that is 30 mm from reference line. So this is the final answer to the fifth case. Let us discuss the sixth case. Let us read the statement. A point F is 30 mm below HP and in VP. Draw projections. Now in this case also, point is not in the quadrant, it is in the plane and it is in vertical plane. And let us understand this situation through the quadrant system. Now when he says in VP, then we must think that there are two parts of VP. One part is above HP and other part is below HP. So let us see about which part he is talking. He is talking about the part which is below HP because he is saying point F is 30 mm below HP and in VP. It means he is talking about this part of VP which is below HP. And in the previous case, we have seen that if the point is in a particular plane, then the other plane has no role in deciding the views of that point. It means in this case also we will ignore HP. Okay, now let us show the position of the point. So this is the position of point F on the vertical plane or in the vertical plane which is below HP and it is 30 mm below HP. Now in this case, if we have to draw the front view, then we will say that rays of sight from the eyes of observer will strike the point and point itself will be its front view and will mark that as small letter F single dash. Now if we have to construct its top view, then observer has to see the point from top. Now again, rays of sight from the eye of observer will project the image of the point on the reference line and that would be called as top view of the point and we label that point as F. Now another point we have to consider over here is that the point is in vertical plane. It means we are not concerned about horizontal plane. It means if we have to represent this situation, then what we will do, we will just draw a reference line and below that reference line we will consider vertical plane and we will not label horizontal plane. And there is no need of rotation of HP even for this particular case because as we said that point is in VP, so HP will play no role in deciding the views of the point which is in VP. So the final case will be that we will represent only vertical plane which is below the reference line. So we'll mark a reference line. Below that reference line we will consider space as vertical plane. Now let us see how we can represent this particular question on paper. So question is a point F is 30 mm below HP and in VP draw projections. So in the previous slides we have learned that this particular situation can be represented on a paper by drawing a reference line and below space means space below the reference line we will consider VP only and there is no need to mention HP because the point is in vertical plane only and HP will play no role. Okay, the next step is that we will mark a reference point on the line. We will call that as small letter F naught. Then we will read the statement. Now statement says 30 mm below HP. That means we have to plot it on opposite plane, that is VP. So where is VP? VP is shown below the reference line. So we will align our scale with this reference point in vertical position and from the reference point we will draw continuous thin line of 30 millimeters and we will make the end of that line bold and that would be called as front view of point capital F and we denote front view by small letter F single dash. In the previous slide through the quadrant system we have learned that if the point is in VP and that is in the lower half of VP, that means below HP, then in that case top view of the point will lie on the reference line. So we will mark top view with the reference point comma F and after that we will place the dimensions. So I hope the sixth case is also clear to you. Now let us move on to the seventh case of projections of a point. So let us read the statement. Statement is a point G is 40 mm in front of VP and in HP draw projections. Now this time the point is in HP. So let us understand this situation through the quadrant system. Now, if you will focus on the horizontal plane, you will find that there are two parts of HP. One is in front of VP and second is behind VP. So if somebody says that point is in HP, then we must think that which part of HP, because there are two parts. One is in front of VP and second is behind VP. So we have to read the statement to get that answer. So you see over here he's writing 40 mm in front of VP. It means he's talking about this part of HP which is in front of VP. Now like the previous two cases, again we have to say over here that as the point is in HP, then VP has no role in deciding the views of that point. So in this case also we will ignore VP and we will only consider HP, and we will consider only that part of HP which is in front of VP, because only that part of HP is mentioned in the question. Okay, now let us show the position of the point. So name of the point is capital G and it is shown in VP and it is 40 mm in front of VP. It was mentioned in the question. Now in this case, if we have to draw its front view, then what will happen? Ray of sight from the eyes of observer will go through the plane and it will strike the point and it will project the view of the point onto reference line. So that view will be the front view of the point. And remember, if the point is in HP, then front view of that point will lie on the reference line. Now, in order to obtain its top view, what we have to do, we have to change the position of the observer, and observer will look at the point from top. So again, ray of sight from the eyes of observer will strike the point, and the point itself becomes its top view, and we label that as small letter g. So we have obtained the two views of the point. Now in this case, we have to understand one very important point, that this time the point was in HP, and we know that HP always rotates in clockwise direction. So as the point is in HP, we are not concerned about VP, so we will totally ignore VP. But we know that HP rotates clockwise. And when we will rotate HP clockwise, this half of HP, which is in front of VP, moves down. It means final representation of this case will be that we will draw a reference line and we will mark space below that reference line as HP. So this should be clear to you. Now let us see how we can attempt this question on paper. So he says a point G is 40 mm in front of VP and it is in HP, draw projections. So from the previous slide of quadrant system, we have learned that in this case HP will be represented below the reference line, because after rotation HP will move down. So you see what we did, we have drawn reference line and space below the reference line is mentioned as HP. After that, we will mark a reference point on that line. Now let us read the statement in order to plot the views. Now he says 40 mm in front of VP. So plot it on opposite plane, that is HP. So where is HP? HP is lying below the reference line. So we will align our scale with this point in vertical position, and from this reference point we will draw a vertical line of 40 millimeters, and this line will be continuous thin. And we'll mark the end of that line bold, and that point will be labeled as top view of the point G. Why top view? Because it is obtained on the plane HP, and on HP we always show top view. Now in the previous slide of quadrant system, we learned that if the point is in HP, then the front view of the point will lie on the reference line. So the reference point itself will be called as front view of point G. So we'll mark comma small letter single dash, which will represent front view of point G. Then we will place dimensions. So I hope this case is also clear to you. Now let us discuss eighth case of projections of point. So let us read the statement. A point H is 40 mm behind VP and in HP. Draw projections. So let us understand this through quadrant system. Over here quadrant system is shown. Now he's saying point H is 40 mm behind VP and in HP. So point is in HP, but which part of HP? Behind VP. It means he's talking about this part of HP. As the point is in HP, it means we are not concerned about VP. So we will totally ignore VP. And we will consider only that part of HP which is behind VP. Means we will talk about this part only. So let us place the point. So the name of the point is capital H and it is how much behind? It is 40 mm behind VP. Now in this case, if we have to plot the front view, then we will say that rays of sight from the eye of observer will project the image of that point in HP on the reference line, and that will be the front view of the point, and we label that point as small letter H dash. Now in order to obtain the top view, observer will change his position and he will look from top, and the rays of sight from the eyes of observer will strike the point, and the point itself will be called as its top view, and we label top view with small letter H. Now again, very interesting point we have to understand that the point is in HP. Which part of HP? Behind part. So we'll consider only this part of HP. So we will ignore VP and this part of HP. Now we know that HP always rotates in clockwise direction. So when this part of HP will rotate in clockwise direction, it will move up. It means final representation will be that we will draw a reference line and above space will be considered as HP. Let us understand how we can solve this case on paper. So as we have learned in the previous slide that in this case we have to represent HP above the reference line. So we'll mark a reference line and above space we will consider HP. Then we'll mark a reference point H0, and now we will read the statement. He says 40 mm behind VP, it means represent that distance on HP. So where is HP? HP is above the reference line. So we will place our scale on the reference point in vertical position, and from the reference point we will draw a continuous thin line of 40 millimeters, and we will place a point at the end of that line and we'll call that point as top view, and it will be denoted by H. And in the previous slide, we have learned that if the point is in HP, then its front view will lie on reference line. So this point will be the front view of the point, and over here we will write comma H dash. After that, we will place dimensions. So I hope this case is clear to you. Now we will discuss about the last case of projections of point chapter. So let us read the statement. He says a point I is in VP and in HP. Draw projections. So it means the point is on the reference line. So in this case, if we have to draw its front and top view, then what will happen? Ray of sight from the eyes of observer will strike the point, and point itself will be called its front view. And in order to draw its top view, observer will change his position, and observer will look at the point from top, and again rays of sight from the eyes of observer will strike the point, and point itself will be called its top view. So it means its final solution will be reference line. On that line we'll mark one point, we'll call that point front view and top view of the point. So how we can represent this on paper? Just draw a reference line on paper and mark a point and call that point as reference point, top view and front view of the point. So I hope all the 9 cases of projections of point are clear to you. Thank you.